Welcome back to the channel. In our last video, we wrote proper threat scenarios. We learned what could go wrong and to which asset. But knowing what could happen isn't enough. We need to know how it actually happens. That's today's topic, attack path analysis. This is where we map out the exact steps an attacker takes. It's clause 15.6 of ISO 21434, work product 1505. And it's the bridge between a threat and a risk. Let's get into it. So, what is an attack path? Simply put, it's the exact steps an attacker must take to make a threat scenario happen. Here's the key difference. The threat scenario answers what could happen. For example, the Break ECU's integrity is compromised by spoofed CAN messages. The attack path answers how does it happen. For example, Step 1, access the OBD port. Step 2, reach the CAN bus. Step 3, inject spoofed frames. One says what, the other says how. And here's an important rule. Every threat scenario needs at least one attack path. If you cannot find a single realistic path to make it happen, then the threat isn't actually possible, and you can drop it. So attack paths also act as a reality check. Now, an attack path is written as a list of steps. Each step is something the attacker must do. Why break it down like this? 3 reasons. First, it's easy to rate. You judge how hard each individual step is, then you judge the whole path. We'll do exactly that rating in the next video. Second, it reveals the weak link. A chain is only as strong as its weakest step. Breaking it down shows you exactly where to add a defense. Third, it keeps you realistic. Listing real, concrete steps stops you imagining impossible attacks. If a step simply can't be done, the whole path stops there. And here's the key principle. Every step in a path is mandatory. If a step can be skipped or done a different way, that's a different attack path. And you write that one out separately. Let's look at a real example straight from the ISO 21434 standard. Our threat scenario is unauthorized access to information on the back-end servers through the head unit. Here is the attack path. 7 steps. Step 1. Rent a vehicle using a falsified ID and credit card. Step 2. Open the vehicle and extract the head unit ECU. Step 3. Research how to get diagnostic access to that ECU. Step 4. Connect debugging tools, for example using UDS or an unprotected JTAG port. Step 5. Dump the memory and reverse engineer the application code. Step 6. Find the part of the code that talks to the back-end database. Step 7. Inject an SQL string into the database query. Now notice 2 things. Every step is concrete. You can picture exactly what the attacker does, and every step is required. Skip one and the attack falls apart. That's what a good attack path looks like. So how do you actually find these paths? There are 2 approaches. The first is top-down. You start from the threat scenario and work down to the steps. You ask, how could an attacker make this happen? Then you break it into smaller and smaller steps. This is the most common approach, and it's where attack trees really shine. The second is bottom-up. You start from a known weakness and work up to the threat. You ask, what damage could this vulnerability lead to? These weaknesses come from your vulnerability analysis or from real security events. And here's a bonus. The bottom-up approach can reveal brand new threat scenarios you missed the first time. In practice, good teams use both directions. Let's talk about attack trees. They're a powerful way to map all this out visually. An attack tree puts the goal at the top and the ways to reach it below. And 2 kinds of branches do all the work. First, OR branches. These are alternative routes. Any one path works. For example, capture the data via cellular OR via Wi-Fi. Either one gets the job done. Second, and branches. These are steps required together. All of them must be done. For example, to capture Wi-Fi, be near the car and run a sniffer tool. You need both together. Look at the little tree at the bottom. The goal is get OTA data. Below it, an OR branch splits into capture cellular and capture Wi-Fi. That's 2 alternative attack paths to the very same goal. This simple structure lets you map even very complex attacks clearly. Now, a question that always comes up. How much detail should an attack path have? Here's the golden test. Is there enough detail to judge how hard the attack is? That's the whole purpose of an attack path, to let you estimate feasibility. No more, no less. Let's see 3 levels. Too vague. Hack the ECU. You can't tell if that's easy or hard. It's useless for rating. Just right. Do fuzzing on UDS service 0x2e across all DIDs via CAN. That's specific enough to estimate the effort. Perfect. Too much. Every single byte, every tool setting, line by line. That just wastes time. Remember, you're rating risk, not writing the actual exploit code. So aim for the middle. Enough to judge difficulty and no more. Let's step back and see the bigger picture. The attack path is the bridge between your threat scenario and the risk rating. Here's the chain. First, the threat scenario. What could happen? We did that. Second, the attack path. How it happens. That's today. You are here. Third, feasibility. How hard is that attack? That's next. And finally, risk and treatment. How big is the risk and what do we do? So what's coming next? Once you have your steps, you rate how hard each one is. That gives you the attack feasibility, the other half of risk. But first, in the very next video, we'll model the attacker behind the path. Who are they? What can they do? That changes everything. Let's bring it home. 6 things to remember. 1. An attack path is the exact steps an attacker takes. It answers how, not what. 2. Every threat scenario needs at least one attack path, or it isn't really possible. 3. Write it as a list of steps. Every step is mandatory. A different route is a different path. 4. Find paths top-down from the threat or bottom-up from a known weakness. 5. Attack trees map it visually. OR means alternative routes and means steps required together. 6. Add just enough detail to judge how hard the attack is. No more, no less. That's attack path analysis. In the next video, we'll get inside the attacker's head and model who we're actually defending against. If this helped, you know what to do. And I'll see you in the next one.